In the summer of 1908, deep in the Siberian wilderness, something happened that scientists still struggled to explain. Early that morning, locals saw the sky light up with a massive fireball brighter than anything else. Seconds later, a deafening explosion ripped through the air, so powerful it shook the ground and flattened trees for miles in every direction. Eyewitnesses said the blast sounded like the world was ending. Entire forests burned, the earth trembled, and then silence. When scientists finally investigated, they discovered something terrifying. The blast was estimated to be between 3 and 50 megatons, thousands of times more powerful than the bomb dropped on Hiroshima. In an instant, 830 square miles of forest were destroyed, millions of trees knocked down like matchsticks. If this had happened over London or New York, millions would have died instantly. But here's the strangest part. There was no crater, no impact site, just scorched earth and trees, all lying in the same direction, as if something exploded above them. The leading theory? A stony asteroid, about 200 feet wide, entered Earth's atmosphere and detonated mid-air. Scientists call this an airburst. On the Torino scale, which measures asteroid impact risk, this event would score an 8, a guaranteed collision with catastrophic destruction. And yet, no large fragments were ever found, just tiny particles scattered in the soil. Some eyewitnesses even reported strange lights in the sky days before the blast. So if it wasn't an asteroid, what was it? A comet? A natural gas explosion? Or something far stranger? After the blast, the shock waves didn't just stay in Siberia, they traveled across the world. Seismic stations all over Eurasia picked it up. Air pressure waves from the explosion were detected in Germany, Denmark, Croatia, even the United Kingdom. And not just Europe, readings came in from as far away as Indonesia and Washington, D.C. Scientists later calculated that in some places, the shockwave was as strong as a magnitude 5 earthquake. Think about that. A blast so powerful, it shook the planet. In the days after the blast, something strange started happening thousands of miles away. Night skies across Asia and Europe began to glow so bright that in places like Sweden and Scotland, people were taking photographs at midnight without using flash. Imagine that. Scientists believe this eerie glow came from high-altitude ice particles formed by the explosion's extreme temperatures, a phenomenon so bizarre it was later recreated by space shuttle launches decades later. And it didn't stop there. In the United States, astronomers at Mount Wilson Observatory noticed something unusual. For months, the atmosphere was hazy, less transparent than normal. The reason? A massive increase in dust particles suspended high above the Earth. This wasn't just a local event, it changed the skies around the world. Almost 20 years after the blast, a Soviet scientist named Leonid Kulik led an expedition to the remote site. What he found was shocking. Around the epicenter where the explosion had happened, trees were splintered and lying flat in every direction for up to 20 miles. Everything was scorched. 2 decades later, almost nothing had grown back. The epicenter was easy to spot because all the trees pointed away from it, like a giant invisible hand had slammed down from above. But here's the strangest part. At the center, there was no crater, just a marshy bog. No impact site, nothing. Eyewitnesses told Kulik they had seen a fireball lighting up the horizon. followed by trembling ground and hot winds so strong they threw people off their feet and shook buildings like an earthquake.
It was just another quiet morning at the Vanavara trading post. I was sitting outside, having breakfast, facing north, when suddenly, the sky split open. Directly over the Tunguska Road, a massive wall of fire tore across the sky, high above the forest. The rupture grew wider and wider, until the entire northern horizon was swallowed in flames. The heat was unreal. It felt like my clothes had caught fire. It was so intense that I instinctively tried to rip my shirt off just to escape it. Then, just as quickly as it had opened, the sky sealed shut. A split second later, a blast so powerful it launched me several meters through the air. Everything went black. When I came to, my wife was standing over me, dragging me back toward the house. That's when the real chaos began. A roar thundered through the air, like a barrage of falling boulders mixed with artillery fire. The ground shook violently beneath us, as if the earth itself was being torn apart. I dropped to the ground and pressed my face into the dirt, convinced that rocks were about to rain down on my head. Then the sky tore open again. This time, a scorching, cannon-like wind blasted through the village, ripping across the land and carving visible streaks into the soil. Crops were flattened in its path. When it finally stopped, all was silent, except for the sound of shattered glass falling to the ground. Later, we saw that windows all around the area had been blown out, and even the iron lock on the barn door had snapped clean in half.
Seismographs in Western Europe even recorded the blast. It was visible from 500 miles away, and because the object vaporized, gases spread into the atmosphere, making night skies glow eerily bright across Siberia and Europe for days. Later expeditions in the 1950s and even an Italian-Russian team in 1999 tried to solve the mystery. Since that morning in 1908, scientists have been obsessed with figuring out what happened. Over 1,000 papers have been written, most in Russian, but the truth is, we still don't have all the answers. The site was so remote, and the technology back then so limited, that modern theories rely mostly on damage reports and geological studies done decades later. The estimates? Anywhere from 3 to 30 megatons of TNT, enough energy to level a major city. But here's the crazy part. No one even studied the area until more than 10 years after the blast. Why? Because the region was nearly impossible to reach, and Russia was in chaos during the 1910s. Finally, in 1921, a mineralogist named Leonid Kulik made it to the Tunguska River basin. He didn't reach the blast zone, but the stories he heard convinced him a giant meteorite had hit. When he got back, he begged the Soviet government to fund an expedition because if he was right, there could be tons of meteoric iron waiting to be salvaged. And that's when the real investigation began. In 1927, Leonid Kulik finally led a team into the heart of the Tunguska blast zone. He hired local hunters to guide them to ground zero, expecting to find a massive crater. But when they got there, nothing. No crater. Instead, they found something even stranger, a zone about 5 miles across, where the trees were scorched and stripped of branches, but still standing upright like ghostly pillars. Farther out, the trees were knocked flat, all pointing away from the center, forming a perfect radial pattern. It looked like the forest had been hit by an invisible bomb from above, and that discovery only deepened the mystery. By the 1960s, scientists finally understood the true scale of the Tunguska blast zone, and it was staggering. The leveled forest covered over 800 square miles, shaped like a giant butterfly, with a wingspan of 43 miles. Imagine that an explosion so massive, it carved a pattern into the Earth. When Kulik first explored the area, he found strange holes scattered across the swampy ground. He thought they were meteorite craters. But after draining one 32 meters wide, he discovered an old tree stump at the bottom. Not a crater, just a bog. Over the next decade, Kulik kept searching. He found dozens of these pothole bogs, but none were impact sites. In 1938, desperate for answers, he arranged an aerial survey, 1,500 photographs capturing the heart of the blast zone. But here's the twist. Decades later, in 1975, the original negatives were burned by order of a Soviet official. Why? Because the nitrate film was considered a fire hazard. The prints survived, but the originals, the closest thing to hard evidence, were gone forever. In the 1950s and 60s, scientists went back to Tunguska, and what they found was tiny but shocking. Mixed into the soil were microscopic spheres made of silicate and magnetite. Later, they even found these spheres trapped inside tree resin. When they analyzed them, the results were clear. These particles had unusually high levels of nickel compared to iron, the same signature found in meteorites. And it didn't stop there. The distribution of these spheres matched exactly what you'd expect from debris scattered by a massive explosion in the sky. Later, studies revealed even stranger metal ratios. Unlike anything in the surrounding environment, all of it pointed to one conclusion. Whatever caused Tunguska came from space. An impact event sounds simple, but it's one of the most violent things that can happen in the universe. It's when an object from space, an asteroid, a comet, or even a meteoroid slams into something bigger, like a planet or a moon. Most of these collisions involve small objects, but sometimes they're massive, hundreds of feet wide, even miles across. When that happens, the result is catastrophic. On worlds with solid surfaces, these impacts carve scars, craters, and basins so huge they reshape landscapes. In fact, impact events have shaped our entire solar system, and even the evolution of life on Earth. Take Mars, for example. There's a crater called Hellas. It's not just big, it's monstrous. 5 miles deep and over 4,000 miles across. That's like an entire continent smashed into the planet. These impacts aren't rare, they're everywhere. And every single one tells the same story. When space decides to hit, it hits hard. The biggest scar left on Earth by an impact is called the Vredefort Dome. 2 billion years ago, an asteroid at least 6 miles wide slammed into what is now South Africa. The crater it carved was monstrous, up to 190 miles across. Today, erosion has eaten away at it. But even now, half of that crater still exists. And then there's Chicxulub, the impact that changed everything. 66 million years ago, an asteroid nearly 9 miles wide struck Earth near what's now Mexico's Yucatan Peninsula. The blast was apocalyptic. Fires raged. Tsunamis tore across oceans, and ash and dust filled the sky. Blocking sunlight for months, the planet plunged into darkness and cold. That single impact wiped out about 80% of all life on Earth, including the dinosaurs. 2 craters, 2 stories. Both reminders that when space decides to hit Earth, it doesn't just leave a mark, it rewrites history. And here's the thing, events like this aren't rare. Smaller meteors, just a few feet across, slam into Earth's atmosphere every few weeks. Most burn up harmlessly, but sometimes they don't. Take the Chelyabinsk meteor, for example, which occurred in 2013. A 56-foot asteroid exploded over Russia. The shockwave shattered windows across the city, injuring 1,500 people, mostly from flying glass. That was just 17 meters wide. Imagine something 10 times bigger. That's why NASA tracks near-Earth objects, asteroids, and comets that swing close to our orbit. Most won't hit us, but some could. And if they do, it's game over. In the 1970s, NASA scientists started studying something called NEOs, near-Earth objects. Basically, giant space rocks that could, one day, slam into Earth. At first, it was just research. In 1998, Congress stepped in and set a monumental challenge for NASA. Track down 90% of all near-Earth objects at least 1 kilometer wide within 10 years. That's massive. An object that size could wipe out entire continents. Fast forward to 2005, and the stakes got even higher. Congress now demanded that 90% of near-Earth objects, 140 meters or larger, be found by 2020. Just one of those could level a city. Here's the chilling truth. NASA admitted they wouldn't even come close. Their own projections suggested they'd discover less than half of these objects. Not by 2020, but not even until 2033. So Congress gave them another job. Figure out how to stop one of these things if it's headed straight for us. NASA calls these objects PHOs, potentially hazardous objects. They're rare, but if they come within 4.6 million miles of Earth, they're on the list. And NASA tracks every single one. Here's the good news. NASA says none of the known PHOs will hit Earth in the next 100 years. But that's only the ones we know about. Since the late 20th century, scientists have been quietly monitoring Earth's atmosphere using satellites and infrasound sensors. And what they've discovered is shocking. Explosions in the sky caused by asteroids happen all the time. Some of these blasts release energy equal to nuclear weapons. Now, Tunguska-sized events, those are on the order of 5 to 15 megatons, are rare, but they do happen. One of the first people to really sound the alarm was Eugene Shoemaker. He was a legendary planetary scientist, often called the father of astrogeology. He studied impact craters and warned us that space rocks aren't just ancient history, they're an ongoing threat. Shoemaker estimated that 20-kiloton events happen every single year, and Tunguska-level blasts about once every 300 years. Recent studies say it might be closer to once every 1,000 years. But here's the kicker. Smaller airbursts around 5 kilotons happen almost annually. Most of these are caused by asteroids, not comets, because they're dense enough to punch deep into the atmosphere before exploding. The biggest one we've ever seen with modern instruments, the Chelyabinsk meteor in 2013. Half a megaton of energy. It shattered windows across an entire city and injured over 1,000 people, and that was just a warning shot. The Chelyabinsk meteor was an exceptionally bright fireball that entered Earth's atmosphere over Russia's southern Ural region. It originated from a near-Earth asteroid roughly 60 feet across and weighing about 9,100 tons. The asteroid approached at a shallow angle of about 18 degrees, traveling at nearly 19.2 kilometers per second, around 69,000 kilometers per hour, or 42,860 miles per hour. It exploded about 18.6 miles above the ground, producing a brilliant flash visible from more than 62 miles away. The Tunguska explosion in 1908 was a wake-up call, a reminder that space rocks aren't just ancient relics, they're an ongoing threat. And if you think Tunguska was a one-time freak event, think again, because just 39 years later, in 1947, the skies over Russia lit up again. This time, it wasn't a remote forest, it was the Sakot-Alin Mountains. What happened there would become one of the most spectacular meteorite falls ever witnessed. And unlike Tunguska, this one left behind thousands of fragments. And a story that scientists still talk about today. The Sakot-Alin meteorite is one of the most spectacular and scientifically significant meteorite falls ever recorded. Classified as an iron meteorite of the coarsest octahedrite group, IIAB, it is composed primarily of 93% iron and about 6% nickel, with traces of cobalt, phosphorus, and sulfur. This cosmic visitor fell on February 12, 1947, in the Sakot-Alin Mountains of eastern Russia, making it one of the largest witnessed meteorite events in modern history. One of the most famous eyewitnesses was P.I. Medvedev, a Soviet artist who saw the fireball while sketching at his window. He immediately began drawing what he saw, and his painting later appeared on a 1957 Soviet postage stamp commemorating the event's 10th anniversary. Locally, the meteorite was initially regarded as an omen, but it soon became a source of scientific curiosity and cultural pride. The Tunguska Event remains one of the greatest cosmic mysteries of the 20th century. A blast so powerful it flattened 800 square miles of forest, yet left no crater. Scientists believe it was an asteroid or comet exploding in the atmosphere, but no one can say for sure. What Tunguska taught us is chilling. Earth is not immune to space. These events happen, and they will happen again. In fact, history has already given us more warnings. The Sakot-Alin meteorite in 1947, and even the Chelyabinsk explosion in 2013. The question isn't if another Tunguska will happen, it's when, and whether we'll be ready, because scientists say events like Tunguska happen every few hundred years, which means we're due. Thanks for watching till the end. I really appreciate you being here. If you enjoyed this dive into the strange and mysterious, give the video a like. It helps the channel more than you think. And if you want more stories like this, don't forget to subscribe to Etan Explains. Thanks again, and stay curious. I'll see you in the next one.